in the same institute from 2021 to 2023. He has received many awards, including the Young Scientist Award from International Journal of Organic Chemistry and Research Excellence Award from Maharashtra Police Annual Academic Award in 2023. He has worked in the science forum for 3 years and gained member of educational हा रेंज आहे. हॅलो सर, आवाज येतोय?
हो, येतोय.
ओके.
येतोय आवाज.
Okay, sir. Dr. Chobe sir received many awards, including the Young Scientist Award 2021, Young Research Excellent Award in 2021, the Maharashtra Police Annual Academic Award in 2023. He has worked in the Science Forum for 3 years and he won first and second prizes for his research work. He has published more than 32 research papers and more than 9 patents. As well as he has written 2 books in organic chemistry. The first one is Fundamental and Functional Group and second one is the Spectroscopic Method of Organic Compounds. He guiding 4 Ph.D. students and also supervised many projects. He has also worked as a co-guide for many students. He has reviewer of the many international journals and guest member of editorial boards. So everyone please join me in welcoming Dr. Santosh Tobe sir. Sir, I kindly request you to please begin your session. Thank you everyone and thank you.
Okay, thank you for the nice introductions. Sir, can I share slide?
Yes sir.
Yes, sir, you can share. I think the screen is visible to all of you.
Yes sir, screen is visible now.
Okay. Okay, so going towards the today's lecture and the today's topic is given for me. That is the just multi-component reactions. So this lecture is nothing but the two-way conversations, and your chat box is also open. Your question answer session means this tab is also open. You can write there if you have any queries, and the question I'm arising, you fully chat box, you have to drop the message in the chat box or otherwise in the question answer box. So basically, start with this topic, that is the multi-component reactions. Outline of this topic, what is an ideal reactions? So all are the beginners in the research, and some are doing in the research in the organic synthesis, material synthesis, and so on area. The most of the students are going through these multi-component reactions. Nowadays, the scenario changes towards the classical methods, move towards the multi-component reaction or multi-component organic synthesis. So, my question is, what is an ideal reaction? What is an ideal reaction? Chat box is open now. You can drop what is an ideal reactions. All these are the points are covered in this lecture. What is an ideal reaction? Definition of multi-component reaction. The comparison of the multi-component reaction, shortly called as the MCR, with the multi-step reactions. These are the two different terminologies with the MCR and multi-step reactions. The history of MCRs, types of multi-component reaction, in which the Pesserini reactions, Ugi reactions, Biglini reactions, and so on. So one by one, we'll cover these reactions for the organic synthesis part. So an ideal reaction is nothing but it is very simple. One pot, 100% yield you got, ready available starting material you can purchase from the markets. You've done the reactions. The starting material is easily available, which is cheap, which is an eco-friendly and resource effective. So these parameters cover if any kind of the reaction is called as the ideal reactions. So these references gives the vendor and Henley in 1997. So such kind of the parameters is done or perform any kind of reaction, which is called as the ideal one. So ideal is nothing but simple to perform and to produce involve minimum number of steps. Preferably, it is a one-pot synthesis. Yeah. You have taken the A and B as a starting material, put it in the round bottom flask RBF, and proceed to the reaction as per your methods. So it is a one-pot synthesis, gives high yield and the selectivity, and consume a fewer resources like the solvent, reagent, and energy. Generates the minimum waste and byproduct. It is called as the simply an ideal organic reactions. We can say that it is the ideal reactions. So why we need the multi-component reactions? The multi-component reaction, which involves three or more starting materials reacting in a single vessels. All the reactant reacts with a single operation to form one main product. The product incorporate most atom of all the reactants with the high atom economy and widely used in medicinal chemistry, combinatorial chemistry, and material sciences. So use of multi-component reaction in organic synthesis. Nowadays, the scenario changes classical approach towards the multi-component synthesis steps. It means in one vessel, you have put it the three or more than three component as the starting material, and you found that one as a single type of the product which is free from any or less or minimization of the side product or the byproduct. So the MCR versus the traditional multi-step synthesis, multi-step synthesis is the multiple stages with the isolation and purification after each step leads to the higher solvent uses, energy consumption, and cumulative yield is lost. These are the multi-step, means if one reactant A adding with the second reactant B to form your product C. And after that, the formation as a C sees your product. Again, it is recrystallization, purification technique, recrystallization, drying, and which is further used for the further synthesis. Means C is your again starting material. You can add D as the starting material in which the E as the product form. Again, E is same drying, purification, recrystallization, again dryings. Again, you have to add F. So it is the multi-step synthesis. So it used the higher solvent uses in which energy consumption is high, and due to the long step or multi-step, the maximum yield is loss. So these are the lacuna of the multi-step synthesis. Now, why? That's why the multi-component reaction is nowadays used everywhere. So all the components added at once or in a definite sequence in the same vessel, and you got a product that is free from, means the less amount of the side product is formation, less energy consumption, as well as the less solvent is used. So avoid the intermediate workup and the purification step, provide a better time, that is the cost effective and a resource efficiency. So these are nothing but the multi-component reaction. So more than two starting material or the compound reacts to form a product in a such a way that the majority of the atoms of the starting materials can be found as the product are called as the multi-component reactions. So main difference between the multi-component or the multi-steps. Multi-step reaction, it is the divergent reaction, and the multi-component, it is the convergent reactions. So divergent is nothing but the A plus B to the formation of C and D. Again, D as your starting material in which E, and you got the H or I as the product. So one step after another or another step again, which is further going on to proceeds to the formation of product is called as the multi-step reaction. But in a multi-component reaction, at a one time in a vessel or in RBF, you have to put it the three reactant or more than three reactants in a vessel or RBF, and to found the product, it is the multi component reaction, which is higher efficiency, high diversity per steps. So it is the multi-component synthesis. So types of the multi-component reaction, in which type first example A plus B to the formation of C, and then again O and P is your product. Means certain types of the striker reactions is there. Second types in which Peyserni reaction and Ugi reactions. If after the completion of C, it is reversible process, but after completion O as converted into the P, which is not in the reverse process, that is the type of the Peyserni reaction as well as the Ugi reactions. Type third, generally seen in the biological systems. This reference from the Ugi et al. And the molecule in 2013 papers, these types of the multi-component reaction is given. So taking the closer at some MCR, isocyanide based MCR, in which the Peyserni reactions and Ugi reaction, which is more suited. And nowadays, the Peyserni reaction as well as Ugi reaction in the research area, it is more likely to be the process or more favorite reactions towards the research community in which the isocyanide based MCRs. The isocyanide-based multi-component reaction, isocyanates are the key components of many modern MCRs. Peyserni-Uggi reaction are the most important isocyanide-based, allow rapid assembly of peptidomatrix and heterocyclic scaffolds are used in the isocyanide-based multi-component reaction. Highly valuable for drug discovery and the diversity-oriented synthesis. So these are the scientists, the first and oldest isocyanide-based multi-component reaction, that is Peyserni reactions. So scientists in 1921 by Mario Peyserni gives these type of the reaction in the multi-component called as the Peyserni reactions. In a simple three-component reaction in which the acid means the substituted acid, substituted aldehyde or ketone means any carbonyl groups, or the isocyanide means substituted isocyanide gives the alpha isoxyamide as the product, in which The carboxylic acid acts as both acid and as well as the nucleophile. Means if you're thinking that your research is the organic synthesis and in which you have to done this multi-component reaction and you have to choose one of the acid, one of the carbonyl compounds containing aldehyde or ketonic and one of the substituted isocyanide group, then definitely the new moiety formation as your product, which is very simply alpha acyloxyamide, that is a substituted alpha acyloxyamide, and which is the new derivatives in your thesis or in your research you have to add. So carboxylic acid acts as both the acid as well as nucleophile here, and the carbonyl compound provides the electrophilic center. And isocyanide participates as a nucleophile and rearranges to the amide. So here is the some suggested mechanism for the Peyserni reaction. Peyserni reaction is the three-component isocyanide-based multi-component and which is oldest isocyanide-based reactions in which basically one of the acid group is required, one of the ketone or aldehyde group means carbonyl ketone or aldehydes, and isocyanide gives the alpha acyloxyamide in one pot. These three components you have to add it in one pot or one vessel and one RBF, and you use the final product that is alpha acyloxyamide as the product formations. The mechanistically gives the isocyanide adds to this carbonyl to form firstly the nitrile or the nitrilium imide intermediate formation, which is trapped by the carboxylate and undergoes Mumm's rearrangement. Mumm rearrangement is nothing but the acyl transfer to offer the product. So it is widely used in the combinatorial synthesis or the medicinal chemistry purpose, as well as in the polymer chemistry, due to the high atom economy and the functional group tolerance. So it is the basic or starting for these three areas, which is largest use medicinal, combinatorial, or the polymer chemistry. So Peyserni reaction. So again, if the today's scenario you have to see or the research or you gone through the literature, you got the number of literature from the multi-component synthesis or multi-component reaction in which the green aspects is very necessary. Nowadays, the conventional methods overcome towards the green chemistry approach. You have to use the number of catalysts, number of green solvents, and by using the 12 principle of the green chemistry, you perform your reaction or you proceed your reaction, gives the high atom economy, the cost effective, and basically which is non-hazardous to the any human kinds or human beings. So we touch here with the Peyserni reaction in the green chemistry aspects or the approach. One pot atom economically process often performed without additional catalyst or under the mild acid catalyst can be conducted in a green solvent such as water, ethanol, and many more. Minimal workup or the purification is required for the synthesis of this Peyserni reaction. These are some drugs are available in the markets in which it is a product of the Peyserni reaction. Synthesis of analog of azinomycin, which is used as the DNA binding and alkylating antibiotics by the Armstrong et al. In which here is one of the acid component is there, one of the carbonyl components means aldehyde components and isocyanide components. So these are the drugs available in the market, azinomycin. So it is the product of the Peyserni reaction. And if you know that before 2 years, the Nobel Prize goes to these DNA double helical structures in which the base pairing is or the codon or this system, the DNA and their binding sites, their research and the coital gives the Nobel Prize. Means nowadays very, very famous, it is the multi-component synthesis like acid component, carbonyl components, and isocyanates. So definitely if you use the novel product and which is number of literature you have to got and you have to synthesis this type of the reaction is one of the topic of your research or your thesis. Application: 1 ethylenic acids, 2 methyl glycidyl in which carbonyl group is there, and a substituted, that is a cyanide, isocyanide group, that is a ethyl isocyanoacetate acetate or acetate, gives such type of the product which is called the azinomycin and its derivatives, which is a very famous drug and which is the product of the Passerni one pot three component system called as the multi-component reactions. Second reaction, in which the Ugi reaction, developed in 1959 by the Ivor Ugi, which is the scientist, the firstly developed this reaction in which the most studied and used in MCR. That is a multi-component reaction, which involves, again, here is also carbonyl, here is also the acids, isocyanides, and additionally, one of the amine group is added. Means one component from the Passerni here is amino group is added and final product as the alpha acyl amino carboxyamides. So it is the multi-component reaction means one pot, four components. And by the definition of MCR, more than two or three components, it is the multi-component reaction or multi-component synthesis. So it is the favorite again, which is developed by the Ugi in 1959. That is one kind of the MCR. So Ugi reaction again touch with the research nowadays scenario changes towards again the green chemistry features or aspects. It is a single pot four component reaction with the excellent atomic economy. Can be conducted in a green media such as PEG 400, ionic liquids, or the water as the solvents. No need to isolate intermediates, require solvent and energy uses, and well suited to the parallel and the combinatorial synthesis. This reaction is also which is used in the combinatorial as well as the medicinal or the polymer synthesis. Developed in 1950s for components, right? And the key aspects or the application of Yugi here is the synthesis of the complex natural product, for the example, descending analogs, generation of diverse small molecule libraries with high throughput the screening, key steps in the synthesis of anti-cancer drug, like for example, actinoacidins, 743 and their analogs, and the construction of the peptide like of the heterocyclic framework in which the Yugi reaction is very important. So mechanistically, the Yugi reaction is, it is the four component in which firstly, it is the isocyanate based multi-component reaction between ketone or aldehydes and amine. First is the ketone or amine or aldehydes or amines means the carbonyl or amines reacts to form the intermediate, the carboxylic acid and isocyanate gives the alpha acyl amide or bis amide in one pot. And this carbonyl and amine to the formation of this imine or the iminian ion attacked again by the isocyanide. This isocyanide on this iminium or imine formation attack, which is attacked again by the isocyanate to give the nitrilium intermediate. This carboxylate attack followed by the mum rearrangement, same as far as the Perricini reactions. And acyl oxygen to nitrogen shifts offer to the final bis amide as the product, which is widely used as the medicinal purposes or the combinatorial synthesis and highly atom economic yield is found. If you go through the multi-step, the yield is very low. Same synthesis, if you proceed with the multi-step, first carbonyl compound like aldehyde or ketone treated with the amines, the intermediate is formed. This intermediate again reacts with the acids. This acid to form nitrolium. Again, this nitrolium attack on the cyanides. Then again the carboxylate attack. It means the multi-step synthesis one by one step is proceeds and maximization of the solvent used as well as the yield is low and which is not suitable for the pharmaceutical purpose. That's why the UGI developed such kind of the multi-component reaction in which four component, which is isocyanate based multi-component reaction here. UGI reaction, formation of imine, as like you have to just shown from the carbonyl compounds and amine, protonation of amines to give the iminium ion, nucleophilic addition of isocyanate to iminium ion, or to formation of nitroleum intermediate. Again, this nucleophilic attack of carboxylate and to form the acyl migration means mum rearrangements and final product as a acyl aminoamides, right? So it is the UGI reactions. So it is the application of UGI reactions. Again, the synthesis of the toxin descending from the sponge Decidia herbarium. So simply in a room temperature 65 hours, but in methanol, which gives only the 30% yield, but the synthesis is a multi-component. Again, different kinds of the here is Fukumiya et al. Had developed the synthesis of the marine tunicates or the ectinexidine 745, which is the anti-cancer drugs, or which is more potent towards the anti-tumor activity, and it is the key step of the UGI reactions. So basically what required here, one of the carbonyl compound like aldehyde or ketone, amine, again isocyanide and the esters to form such type of the product. The variation of the functional group of UGI reactions. So why the lacuna or the majority of the variations can be made at the carboxylic acids. If you doing in your research one of the topic for these UGI reactions, so you have to proceed through the substituted aldehydes or carbonyl-like compounds, one of the substituted acids, isocyanides, that is the substituted isocyanide, and the amines. But majority of the variations can be done in the acids. So use here the cyanic acids, hydrogen thiocyanates, hydroxoic acids, and so on. And also, the few changes can be made in the amines, that is the derivative of ammonia here used, such as hydrazine, hydrazides, or hydroxylamine, also used for this formation of the UGI product. Like definitely you have to go the maximum yielded product, that is the novelty one. This reaction is 100% novel one if you use these two variations in acids and amines. So limitation of UGI and Pesarni, where is the limitations? The Pesarni reaction, it is the three component or also called as the multi-component in which the three reactant molecules, you know that the carbonyl compound like aldehydes, ketone, acids, and isocyanide. And UGI reaction, one amino groups is added. Rest of the three are the same. So overlap between UGI reaction and Pesarni reaction, side product of each other, limited use of amine in a Pesarni reaction means somewhat amines also used in the Pesarni reactions, but the yield is low, and that's why UGI move forward towards this Pesarni and gives the UGI reaction as a specialized multi-component synthesis. So what is the basic difference between these Pesarni and UGI reactions? So here is the Pesarni reaction. You know that it is a three component isocyanate based MCR. UGI is the four component. Here is the starting material carbonyl, acids, isocyanide. Here is the amine as one of the extra components. Product alpha isoxylamide, which is in the Pesarni reaction. And in UGI reaction, it is the alpha acylaminoamides. The key new bonds, it is the CC, or that is the conversion of CC and CN. Here is the bis amide, that is the CC, CN, which is the twice or it is a bis amide. The first step in the Pesarni, nucleophilic attack of isocyanide on the carbonyl, and in UGI, imine or iminium formation, that is came from the carbonyl or amines. And the main cationic intermediate here is the Pacernate is the nitrilium or immediate type of the species is the form. And in Ugi, the iminium or nitrilium intermediate is formed. Here is the role of nucleophilic means carboxylic acid is the carboxylate in the Pacernate, and the protonates imine, that is the iminium formation, and the nucleophile here is the carboxylate. In both the isocyanate addition to the carbonyl followed by mum, here is the imine formation, isocyanate addition, and after that carboxylate attack towards the mum rearrangement. Both in case the mum rearrangement synthesis or the migrations is performed or you have to shown, and typically the very high atom economy, which is very most powerful parameters for both the reactions, very high atom economy and less or minimization of the side product or the byproduct. The solvent used aprotic, that is THF, CH2Cl2 or the green variant, as like the green solvents, ionic liquids, PG 400 and so on. And here is the polar protic solvent like the methanol, ethanol, and the polar aprotic also. Usually, these reactions are the room temperatures and gives the high yielded product as you have to show. Third reaction, that is a multi-component reaction, which is very, very favorite and nowadays very popular reactions. You have to say that that is the Biglini three-component reaction. So this Biglini is discovered by Pietro Biglini in 1891, and the major component of this reaction is the aldehyde beta ketoester, urea as well as the thiourea, and gives the product as the dihydropyrimidinones, in shortly called as the DHPMS. These are typically acid catalyzed condensation reactions. So, which is developed in 1893, the Italian chemist Pietro Biglini, which is a classical non-isocyanide based multi-component process. Before Pesirni and Uggi reaction, which is isocyanide based, but the Biglini is a classical and a non-isocyanide based multi-component synthesis or reaction. Involves an acid catalyzed condensation of beta ketoester aldehydes, or the carbonyl group means aldehyde and the urea or thiourea is used in presence of alcohol, gives the final product as the dihydropyrimidinone or its derivatives. So beginnerly in mechanistic pathway, the formation of iminium ion from aldehyde and urea or thiourea, then nucleophilic addition of beta ketoester to the iminium ion. Again, the cyclization towards the dihydropyrimidinone ring system and dehydration to give the final DHPM product. So these are the mechanism in which aldehyde group, if you use X as the oxygens means urea, and if you use the X as the sulfur as the thiourea, which is in the acid catalyzed reaction to gives the intermediate, and this nitrogen ion further gives as the final product, that is a dihydropyrimidinone. Means the beginning reaction is the classical three component condensation between aryl aldehydes, beta ketoester, such as ethyl acetoacetate, urea or thiourea under the acid catalyze to give the 3,4 dihydropyrimidinone DP, DHPM, we can say that. And mechanically, it is the urea first condenses with the aldehyde or the thiourea first condense with the aldehydes to form iminium intermediate, and which is undergoes the Menich type of the additions by the enol form to gives the beta ketoesters, and followed by the intramolecular cyclization offered gives the dihydropyrimidinone, which is widely used nowadays. That is the Biglini reactions. So biological importance of the Biglini reaction is what? So dihydropyrimidinone exhibit a diverse pharmacological activities such as antiviral, antibacterial, anti-cancer, and so on, antihypertensive, and basically nowadays the research towards moving with the calcium channel blocking activities. So example for this, benzylidene B and related marine alkaloids, which is the example of this Biglini type of the product, which is available in the market, which is clinically proved drugs and which is available in the markets in antiviral, antibacterial, and anti-cancer properties. So move towards again the green approach towards the beginning. So this reaction also carried out in presence of FeCl3, ZnCl2, or copper nanoparticles as a catalyst. Solvents such as ethanol or water are used any green kind of the solvents like PG400s or the catalysts, amberlites, geolites you have to use. Again, these reactions are possibility of the solvent-free reactions and gives the minimization of the waste product and nearly about 95 and more percentage of the yield you have to found with the microwave assisted condition if you use in the Biglini reactions. Means the parameters with high yield, short reactions time, and easily work up reaction, that is the Biglini reaction. If you choose on one of the topic from your thesis or your research, you can collect these three components, urea or thiourea, aldehydes, and any ester means ethyl acetoacetate, and so on. So you have to find the dihydropyrimidinone derivatives, which is again the novel, but you have to use the novelty in the aldehydes group, or you have to use with the ethyl acetoacetate as the substituted derivatives. So which gives the high yield, short reaction time, and easily work up. Means isolation is very easy. Again, the application of these Biglini reaction, they have found exhibit a wide spectrum of the biological effects, as like the antiviral, anti-tumor, antibacterial, anti-inflammatory, like the alkaloids, which is are effective in HIV, GP120, CD4 inhibitors. So these structure showing that which is available in the market as the product of this Biglini reaction as the benzylidene B. So it is acts as a anti-tumor and anti-inflammatory as well as the antibacterial agents. So if you're thinking that you have to perform such type of the reactions, number of literature is available on a Google or various sites, and you have to perform these simple, easily workup procedures for these Biglini reactions, and you have to combine one of the topic in your research, that is the Biglini reactions. Again, the Straker multi-component synthesis of amino acids. The components here, aldehydes, ammonia or amine or hydrogen cyanide. And you use the product as the alpha amino nitrile, which can be hydrolyzed to the amino acids. One of the earliest known MCR in 19th century. And important, it is the prebiotic chemistry and amino acid synthesis. So Straker multi-component synthesis in which aldehyde or ketone is reacts with these these hydrogen cyanides in one pot to form alpha amino nitriles, which is on subsequent hydrolysis yields corresponding to the alpha amino acid. The firstly, aldehyde is condensed with the ammonia to form an imine or iminium ions, and this attacked by the cyanide to gives alpha amino nitrile as the product. Again, hydrolysis of this nitrile group converts into the carboxylic acids or completing the amino acid structures. So these multi-compound synthesis are nowadays boom in the markets because of the less duration of the time, easily available starting material, and easily available again solvent system. You have to use green methods or simply solvent system if you got the clear less duration time and high yielded product. Again, the Hansch multi-component synthesis of dihydropyridine synthesis, in which again the aldehyde, beta ketoester, ammonia. So number of multi-component reaction is there. Hansch process as the product, one for dihydropyrimidine derivatives. The main structure are mainly used in the calcium channel blockers. Example, nifedipine as a drug which is available in the market, which is example of this Hansch multi-component synthesis. Again, this Hansch dihydropyrimidone synthesis, it is the four-component multi-component condensation reaction. That is the two equivalent of the beta ketoester or aldehydes and ammonia or the ammonium acetate to gives 1,4-dihydropyridine in one pot. And mechanistically, the novel condensation between beta ketoester and the aldehyde forms and the aryridine or the beta ketoester. While in the second, the beta ketoester to form enamine with ammonia and proceeds through the Michael addition to form the enamine or activated double bonds, followed by the intramolecular cyclization or the tautomerization offered the 1,4-dihydropyridine ring, which is the scaffolds of the calcium channel blocker drugs. These are very famous drugs. Nifedipine, which is available in the market, and it is the calcium channel blockers. Again, the amenable to the green approach towards this Hansch process, you have to use the nano MgO, magnesium oxide, L-proline. You have to use this catalyst. Again, the reduction or reduce the time for completion of your reaction, as well as the maximum yield of your product is achieved. By using such type of the green approach, you have to perform in your reactions as a solvent, as a catalyst. So you're thinking that the multi-component reaction and the green approach towards the multi-component reactions. Again, which is very favorable reaction, a favorite reaction, that is Manish multi-component reaction. Again, the aldehydes, often formaldehyde, amines, or the active methylene compounds to gives the beta aminocarbonyl as the compound as the product, which is widely used in the synthesis of the pharmaceuticals and the fine chemicals. In a pharmaceutical, a number of batches is performed by this process to got the result of the manage like the final product or the basic product, that is the multi-component reaction. So now move towards the era of the pharmaceuticals, any kind of industry you have to see. There is maximum utilization of the process or the R&D is developed, which is the less duration time for the completion of the reaction, which is free from solvents. Like if you use the green solvent, means which is not hazardous to the human mankind, or if we use the catalyst. So many of the pharmaceutical companies or the pharma or any kind of the companies which R&D works on that, such type of the multi-component synthesis is performed. So thinking about that, if you are beginner, so think about that. If you go through these multi-component reactions, if you cover this multi-component in very short or less duration, you have to complete your one of the chapter from your research work or thesis. As you have to choose on as the heterocyclic scaffolds or heterocyclic chemistry, which is further or more application used. Again, the petasis borono-Manich reactions. Here is the aldehyde, secondary amines specially, and the boronic acids. And the product form is the substituted amines with the high stereo control product. It is metal-free, often performed under the mild and the green conditions, which is useful for the building complex amine or which is used in the medicinal or pharmaceuticals in means the polymer chemistry purposes. So like of number of multi-component reaction is there, right? These multi-component. So I have to prepare for you why these multi-component reaction, it is combined with the green chemistry approach and what is the uses for your research. So MCR within the framework of the green chemistry, which is high atom economy, means which is obey the principle of the green chemistry that is proposed by the Anastas. High atom economy, maximum incorporation of the reactant atom into the product. It is the basic need of each and every industry. Prevention of waste by reducing number of steps and workup operations. Again, energy efficiency through mild temperature and the shorter reactions time. Use of greener solvents or a solvent-free condition for performing such kind of the multi-component reactions. One-pot synthesis and waste minimization avoids isolation and purification of intermediates, reduce use of extraction solvent and the chromatographic material, as well as the E factor, mass of waste per mass of product. These are the very important factor or the key intermediate for any kind of the industry, or if you scale up the reactions with mass of waste per mass of product, you got the maximum yield of your product. Simplifies a scale up for the industrial application. Solvent and energy efficiency in MCR. Many MCR operates efficiently in water, which is universal solvent, easily available, ethanol, P400 or ionic liquids, possibility of conducting reaction at a room temperature or a mild heating. Microwave and ultrasonic assisted MCR further decrease the reaction time. Means number of method you have to develop for proceeding such type of the multi-component reactions. If you go through the microwave, your time duration or reactions time is less. Again, if you go through the ultrasonic assisted MCR, again decrease in the reactions time and number of method you have to develop for such kind of the MCR. Reduce energy consumption and the carbon footprints. Catalyst you have to use in the multi-component reactions. The catalyst enhances the rate. You know that what is the role of catalyst? Everyone know the role of the catalyst. So catalyst enhances the rate, the selectivity, and the sustainability of multi-component reactions. Homogeneous acids and base catalyzed, Lewis acids and transition metal catalyst, organocatalyst and biocatalyst, heterogeneous and recyclable catalytic system. If you use the recyclable solvent, if you use the recyclable catalyst in the MCR, if it gives the number of means catalyst is used the number of cycles. Means the catalyst used in the first reaction for completion, again this catalyst again used for further reactions, again used for further and so on. Means at least 3 to 4 times the efficiency of catalyst is done as well as the solvent. If you reusable or the green solvent you use, again which is further used. Acid catalyze, mineral acid HCl, H2SO4, H3PO4, organic acid you have to use, the camphor sulfonic acid, solid acid, Amberlist 15, silica sulfuric acid, zeolites, and used in the beginning manage and related condensation MCR. So these mineral acid, organic acid, solid acid, catalyst you have to used in the Paracini, beginning, manage, and the related condensation multi-component reactions. Lewis acid here you used the ZnCl2, LCl3, FeCl3, copper chlorides, activate the carbonyl compounds towards the nucleophilic additions. Improve the yield and lower reaction temperature, can be supported on a solid material for easy recovery. Nanoparticles now again used And the scenario changes. We use here the nanoparticle for completion of our multi-component reactions. Here is nano ZNO, nano Fe3O4, nano copper oxide used in the various multi-component reaction. If you go through the literature, you have to found that number of nanoparticles or these nanocatalysis is used for the completion of such kind of the multi-component reactions. High surface area and selectivity with a potential for recyclability. Supported catalyst on silica, alumina, clay, the monomethyl simply separation and reuse for suitable for the green scale synthesis. So these are the metal nanocomposites or the catalyst is used for the multi-component reactions. Green catalyst used in big linear reaction with FeCl3 or nano-copper catalyst in ethanol or water. Pearson reactions carried out with the water or little. Or if no catalyst is used, if you are doing the less duration time for completion of these Pearson reactions, why we adding such type of the catalyst? If no need, you have not put it in the catalyst for the reactions. But if the time duration is somewhat longer as per your view, so you have to add one of the catalyst and check it. If this addition of this catalyst, our reaction time duration is less or not. In UV reaction, Pg400 or ionic liquids under the solvent-free conditions, Hanch reactions promoted by the L-proline or the nano magnesium oxide in ethanol. So number of literature, if you go through the MCR, you are giving. Industrial relevance of green MCR. In a pharmaceutical industry, rapid generation of drug-like libraries is needed. So in the industrial purpose, they are in their R&D sections, means research and development. These are number of reactions they are set up or scale up these reactions for drug-like product they are formed with the help of these multi-component reactions. By using number of catalysts in there, by putting or adding the number of green solvent is there. So these are the scale-up reaction in the pharmaceutical industry. In agrochemical industry, the discovery of herbicides, pesticides, and fungicides in which multi-component reaction is used. Material chemistry, functional polymers, and a supramolecular system in which the multi-component reaction is used. Again, the automation and the high throughput synthesis enabled by a simple one-pot protocols in which the multi-component reaction is used. Here is the 12th principle of green chemistry, which is based on the multi-component reactions, prevention, atom economy, one of the factor, less hazardous synthesis, designing safer chemicals, safer solvents, and the auxiliaries, energy efficiency, use the catalyst role, use of renewable feedstock, reduce derivatives means avoid unnecessary derivatizations, right? Again, here is the blocking groups, protection, deprotection, and designing for degradation. Product should be break down into the harmless of substance after use. Real-time analysis. How much time is required for completion of the product or by the side product, which is not hazardous. So again, the multi-component reaction, which is naturally supports several these principles. And the key links, basically, the atom economy is very important. Waste prevention, catalysis role, safer solvent, as well as the energy efficiency. These are the key points of the multi-component reaction synthesis. Atom economy and its factors. These are the work example atom economy of quaternary reactions. Right? Consider the reaction benzoic acid, benzaldehyde, tertiary butyl isocyanide gives alpha isoxyamide as the product. So nearly all atoms from the three reactant appear in the product. Only minor loss in the workup. It is the beauty of this reaction. Right? So less amount of side product byproduct formation easily work up, and the minor loss of the reactant atom, it is converted into the product. It is the beauty of such kind of the reactions. These illustrate the intrinsic atom economy and the typical of isocyanide based multi-component reactions. So designing a multi-component reaction, step identify the core scaffold of the target molecule. If you go through your research, your proposal, just look at that. And if you know, you have to prepare the alpha isoxyamide or dihydropyrimidinone is one of the topic or one of the chapter from your thesis or your research work. So firstly, identify your core scaffolds or the target molecule firstly. Then second step, map each fragment of the scaffolds to the corresponding components like acids, carbonyl, isocyanide, and etc. Map this corresponding, which is available for you. Step 3, choose a starting material that contain these fragments and are easily available or readily available and which is very cheap. Step 4, optimize solvent. If you use the catalyst, then catalyst and the condition with the green chemistry in mind. Always mind that such kind of the reactions, if you have to perform, then use the green chemistry approach in it. So it is the non-hazardous towards the human mankinds. And globally, and nowadays, the scenario goes towards the green chemistry approach. So thinking on that. Example for designing a Biglini reaction, target 4-aryl dihydropyrimidone with a ester substituted at carbon number 5. Choose aldehyde as the para-methoxybenzaldehyde for electron donating aryl groups. Here we use the example for you. Then choose the beta keto ester like the ethyl acetoacetate or ester side chain, any ester. Again, choose the urea or thiourea and tune hydrogen bonding and check its biological activity, which is very important. If you prepare such kind of the targeted molecules in your laboratory and you have to check their biological activity, such type of your novelty of your compound in the future, it's no doubt it happens as one kind of the drug or drug formation is there. So again, thinking on that, we move towards the classical and multi-components route. The classical linear routes gives the condensed aldehyde with urea and formation of intermediate. Again, this intermediate with the beta keto ester in a separate step, purify this intermediate at each step. But the multi-component reaction route says that one pot combination of all three components in one vessel or one RB, which gives the shorter reaction time, less waste, and the better overall yield. These are again the beauty of the multi-component reactions. The green solvent approach towards the multi-component reactions. If you use the universal solvent as the green solvent like the water, which is highly benign, inexpensive, and often rate enhancing for the polar reactions. If you use the PG400, which is non-volatile, recyclable, and effective medium for Pesserni and Uggi reactions. If you use the ionic liquids and the deep eutectic solvents, which is tunable, the polarity of often, which is reusable solvent. Again, the PG400, which is used for the green alternative to volatiles organic solvent. Advantage is what? The low toxicity, high boiling points, recyclability, and the good solubilization power. These are the advantages of the PG400, means the green solvent if we used in the multi-component reactions. Promotes Passerni reactions, Uggi, Biglini, at a mild temperature or at a room temperature. These reactions happen always at room temperatures. If you use the different kinds of the method like the photocatalysis, sonicator, or the microwave assisted, it gives the easily workup and short reactions time. Deep eutectic solvents like DES in MCR. DES are the mixture of hydrogen bond donor and acceptor with a melting point diffrations. Example, a choline chlorides like the urea, choline chloride like the glycerol, etc. Use this, which is advantage again, the low volatility, easy preparation, often biodegradables, and which is used in the MCR like Bigelini, Manage, Hanch with easy catalyst recovery. Again, the heterogeneous catalysts in MCR used. These are the for case studies. If you use the Fp304 nanoparticle as a catalyst in the Bigelini or Hanch process or reactions in ethanol or water, again the Morillonite K10 clay promoting the Meinich and Hanch processes. Number of literature you have to got for such kind of the clay catalyst is used for the multi-component reaction system. Again, if you use the sulfonated silica or the polymer acting as a solid acid for Peyserni and Ugi reactions, and reusability of catalyst demonstrated over the multiple cycle with the minimal activity loss. These are the multi-components again. Organocatalysis in asymmetric MCR, green features, low loading, mild condition, and compatibility with aqueous media, which is easily available. Again, chiral proline derivatives enable enantioselective selective Manish type of the reaction. Organic catalyst avoids metal contaminations and important for the pharmaceutical synthesis. High urea based hydrogen bonding catalyst for the stereoselective isocyanide used in the multi-component reactions. Biocatalyst, the enzymes like lipase used to catalyze the domino or MCR like processes in water, which is again high selectivity. Chemo, regio, and enantio selectivity under the mild condition by using this biocatalyst. So you use different kind of the catalyst is available in the market, green solvent is available in the markets, and you perform such kind of the reactions, that is the multi-component reactions in your laboratory, and you found a excellent yielded product with minimization of your solvent or the byproduct. The potential to couple the enzymatic step with the classical MCR in cascade sequence and future direction, a fully biocatalytic multi-component process in aqueous media. Nowadays, big research going towards the using the biocatalyst in multi-component reaction. A role of MCR in a drug discovery, which is very important because we synthesize number of compound in our laboratory. Number of derivatizations we have to prepare or process in which number of molecule we have to synthesize in our laboratory. But what next? If you thrown all such type of the derivatives or the sample or the products. So here is the role of MCR in the drug discovery. So it is a rapid access to diverse small molecule libraries for hit and lead identification. The scaffold for these heterocycles, privileged structure, dihydropyrimidines, and a compatibility with a parallel synthesis and the high yielded throughout the screening. These MCR help explore a large chemical space with the relatively small synthetic efforts. MCR in diversity oriented synthesis means dose aims to generate a structurally diverse molecule from simple building blocks. A simple molecule you have to use, combine these three components or four components in one vessel, and you have to proceed this reaction called as multi-component reactions, and a diversified oriented synthesis you have to got the results. If a substituent changes on each component, rapidly expand chemically diversity. And basically, it is useful for the probing structure activity relationship, in short called as the SAR, means SAR in a medicinal chemistry. Again, the environmental and economic benefits of MCR, which is again very important parameters: lower solvent consumption and waste disposal cost, reduced energy usage due to a short reaction time and a fewer step, simplified equipment and labor requirements in an industrial setting, and overall, the reduction in a process cost while improving the sustainability of the matrix, which is the beauty of this MCR, environmental and economic benefits. Again, what is then limitation and challenges of the MCR? The compatibility issue, not all functional group tolerate one pot condition, right? These are the limitations. Selectivity, a multiple possible product if components are not properly chosen. The reaction is not proceeds, means selectivity is one of the major parameters or the factors for proceeds these multi-component reactions. Optimizations can be complex due to the multi-parameter space, four or more reagents, and a need for a better asymmetric variants and catalyst with a broad substrate scope is available. So these are some limitations and challenges towards the researcher for the multi-component reactions. So what is the future directions in multi-component reactions towards the research? So development of new catalytic system, photoelectro and the biocatalysis, integrations with the flow chemistry for continuous and safer production, a combinations with the computational design to predict optimal component sets, and application to synthesis of a complex natural product and a functional material. So these are the future direction for the multi-component reactions. So here is the key take the home message. Why we chosen the multi-component reaction in our research and where we used. The multi-component reactions are the powerful tools for rapid construction of the complex molecule. Firstly, they align strongly with the principle of green chemistry, means atom economy, waste minimization, and the energy efficiency. Here again use the green solvent and the catalyst, heterogeneous organo and biocatalyst for further enhance the sustainability. And mostly these MCR are increasingly important in the modern synthetic, medicinal, and the material chemistry. So why we chosen multi-component reaction? Because of these all over the parameters are covered. So these are the readings for references. And the conclusion of this multi-component reaction system is over the 150 years of the development for Passerni, Ugi, Bigilini, Hunch, Stretcher, and so on. The past, future, present, and the future for you as a researcher. So think about that and go through the multi-component synthesis in your research work by using such the parameters you have to just shown here, I'm showing here, and proceeds your reactions with again the aspects of the green chemistry. And now some question from my sides. Your chat box is open. The question answer box, our session is open. You have to put your answer in a chat box or question answer. So my first question is, a multi-component reaction is best described as. I go through the all slides, all PPTs, all my lectures. The first question for you, a multi-component reaction is best described as. Your option now, a reaction run in a two separate flasks, a one-pot reaction involving three or more components, a catalytic hydrogenation step, a polymerization of monomers. Your chat box is open. B, 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 B. Manisha saying B, Rihanna saying B, Yogita saying B. Drop a chat box. Okay. B, 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 B. So it is a one pot reaction involving three or more components. It means you have to got what I'm saying, that the multi-component reaction is used for your research. That is the one pot reaction involving the three or more components is right answer. Again, the second, the main advantage of MCR over the classical multi-step synthesis. Your time start now. Yes, one of the answer from Sonali. C. Again, Manisha C. Yogita Thorat C. Rihanna C. Other students. Ekta Kumari C. Shvetali Kulkarni C. Okay. Other student, I think. Okay. C. Sagar Shinde C. Okay. So the main advantage over the MCR over the classical multi-step synthesis is the better conversion and atom economy, which is right answer again. Again, the next question for you. In the Passeri reaction, the product form is a beta amino carbonyl compounds, 1,4-dihydropyridine. C is alpha acyloxyamide, or D is the alpha amino nitrite. Your time again start now. In the Passeri reaction. Again, C. Rihanna say C. Kumari Ekta. Okay, Ekta Kumari C. Manisha C. Okay, Yogita Thorat C. No other answer. Again, try for the other students and give the answer. In the Passeri reaction, the product form is. Earlier, we show the mechanism, their multi-component reaction, their synthetic pathway or routes, okay, the products, and here asking for the product name. So it is again right answer, that is alpha isoxy amide as the product for the Pacerney reaction. Again, the fourth questions, a typical four inputs in the UV reactions are, means the reactants is used for the UGI reactions. Ariana say B, aldehyde, ketone, amine, carboxylic acid, isocyanide. Sagar Shinde also give the answer B. Again, Yogita Thorat also say the option as a B as the reactant for the UGI reaction. The correct answer is B. Again, say the Sonali. Some more students. Come fast. B. Ekta Kumari say B. Okay. Shwetali. Okay. Shwetali say B. Khan say B. Okay, so the typical four inputs in the UGI reactions are the aldehyde or ketone, means the carbonyl compounds, amines, carboxylic acid, and isocyanide. It means one of the reactant for the Pacerney reaction here is, rest are the same for the Pacerney. One of the component, that is amine, is added. So it is the carbonyl compound like aldehyde ketones, amines, carboxylic acid, and isocyanide is the right answer, and the option is B. Again, the question, the original beginning reaction gives A. Dihydropyrimidinones, B. Beta-lactam, C. Imidazoles, or D is a oxazoles. Okay, Rihanna Khan say A. Sabre Yuvraj say A. Manisha say A. Fast. Khan Tarannum say A. A. Sagar Shinde A. These are the simple questions already, all the PPD, and we cover all the points, and we are asking some questions to you for your practice. So original beginning reaction, it is also the multi-component reactions, and the product for is the dihydropyrimidinones derivatives, right? So it is the A option is the right answer. Again, the question for you, which combination correspond to the Straker synthesis? Straker synthesis. Sabe Yuvraj B, Yogita Thorat B, Rehana Khan B. Straker synthesis. Other students, fast reply. Chat box is open for you. Khan Tarannum B, Shinde Sagar B. Other student also B. B. Okay, so which combination correspond to the Straker synthesis? It is the aldehyde, ammonia, and hydrogen cyanide, that is SCN. Okay, next question for you again. A green features of one part MCR, means multi-component reaction, is green features. A option is the high melting points of product, increased use of protecting groups, reduced solvent and workup requirements, need for high temperature and pressure. Rayana Khan says C, Sabre Yuvraj C, Shinde Sagar C, Khan Tarannum C. Fast, other student, chat box is open for you. Ekta Kumari C. right? So by using the green principle or the approach towards the green chemistry towards the multi-component reaction, here is the question, the key green feature of one pot MCR is. So the correct answer is reduce solvent and workup requirements. All are gives the right answer, that is a C. Next question again for you. Which of the following is a solid acid catalyst used in MCR? The option first NaOH, B option amber list 15, C option pyridine or triethylamine. Okay. Rihanna Khan B, Thorat Yogida B, Sabay Uraj B, right? Khan Tarannum B, Sagar Shinde B. Okay, all rest are bases. All rest are bases. Shinde Sagar B. So the question is, which of the following solid acid catalyze used in the MCR? Which is right answer. Amber list 15 is the right answer. Okay. So again, the question for you, PG400 is used in multi-component reaction. It's mainly as first oxidizing agent, B reducing agent, C non-volatile or recyclable, or the phase transfer catalyst. Your time start now. Ekta Kumari says C. The question for you again, the PG400 is used in MCR mainly as Sabai Yuvraj says C, oxidizing agent, reducing agent, non-volatiles, recyclable solvent, or last that is a phase transfer catalyst. C, Shvetali C, Kantaranum C, Sabai Yuvraj C. It means, okay, Shinde Sagar also C, Sonali say non-volatile, recyclable solvent, that is C. Okay, so everyone give the right answer. That is the C as the option, non-volatile and the recyclable solvent. And the last and 10 questions from my side to you. That is the parameter E factor refers to A, energy of activation, electric conductivity. C is a mass of waste per mass of product, and D, extent of conversion. Okay. Sonali C, Rihanna Khan C, Khan Tarannum C, Ekta Kumari C, Sabre Yuvraj से C, शिंदे सागर से C, श्वेताली कुलकर्णी से C. Okay. So the parameters of E factor we already shown, or the formula for E factor also discussed, that is the mass of waste per mass of product, and everyone give the right answer. It means that the multi-component reaction, if you got 100%, so use these multi-component reaction in your research and made a topic, one of the from your thesis or your research, as the multi-component synthesis. By using such kind of the catalysts, using green solvents, by using the obey the green principle, that is the 12th principle of green chemistry, and number of literature is available for in Google Scholar, or number of sites is available to download the literatures and go through the multi-component reactions literature, and made a one topic for your research or thesis as the multi-component reactions of Pessarni reactions, Biglini reactions, Hunch reactions, Streicher reactions, and all. So again, the chat box is open, or the question answer is open for you. You can ask the questions for this multi-component reaction system. Nowadays, very big boom for these multi-component reactions by using more than 2 or 3 components in one vessels and use the very high yielded product, which is the very beauty of, and that is the beauty of this multi-component reaction system. Any question? We want the question from your side, as you are the researcher now. Sir, in exam, which type of the questions will be asked, MCQ or descriptive? Okay, that pattern or that MCQ or descriptive type of questions, let you know the coordinators in some time, or you can practice MCR as well as the descriptive, the patterns, let you know for some times. No? Again, any question? Okay. So, no question from your side. So, can we stop here, sir?
Yes, sir.
Okay. Madam, please continue.
Huh. On the behalf of all the participants, I would like to express my sincere thanks to Dr. Santosh Sobe sir for giving us such an informative and inspiring lecture. Sir, we are truly grateful for your time, your knowledge, and your valuable guidance. I also thanks to Dr. Ahiri sir for their efforts and making this program successful. And thank you all participants. Thanks.
Thank you, Iris sir, for giving this opportunity to me to express my views on the multi-component reaction system towards the researcher or research scholar who are the beginners in this research area. And assume that all the researchers going one of the topic or made one of the topic for this multi-component reaction system, and which is included most valuable and high impacted papers from the research or the research scholar sites. Thank you once again. Can I leave, sir?
Yes, sir. Yes.
Okay.
Thank you, sir.